Go ahead. Sorry, Maya.
The interior and the interior points again.
Okay, so the difference between the interior and the exterior points. Interior point, well, we don't really, the interior points would be, anything but the endpoints. So if you have like from anything in between, oh, I messed up my graph. Anything in between A and B, not including A and B.
Okay.
Sammy?
Just curious, do you put vocab on your quizzes too? Or like tests?
No. No vocab. Okay, I scrolled too fast. Oh, I keep going past. Okay, so here we are with the next part. This is where we always get hung up because we forget how to graph, like rational functions. I mean, I hope we remember how to do parabolas. But let's have our calculator available just in case we need to confirm something. Okay, the next thing we want to look at is we want to identify the domain, the range, and sketch the graph. Okay, all right. So let's review. Domain is what we can plug into the function, and the range is what we get back out. So domain would be what possible x values we could have, whereas the range, we're looking at the y values. Good? And then we're going to sketch. Sometimes it's helpful to sketch it first and then come up with domain and range. Shall we do that? Yeah. Okay. So let's start with the first one. It's y equals 2 minus x squared. If it helps you to write it as negative x squared plus 2 so that we can see it's an upside down parabola and it's been moved up 2 units. We're okay with that transformation? So up to a sketch. When I say sketch, you don't need to just, there's your vertex, draw an upside down parabola. Because I'm specifically looking at domain and range here. There will be a time where I want you to be very, very accurate, but these should be quick. Just quick sketch the graph so I can determine domain and range.
So if it says plot the graph.
Right, if I want more detail, I'll tell you. But whenever I use the word sketch, just, it's fine. It's fine, just a sketch. Domain. What's domain?
Negative infinity.
Okay, negative infinity to infinity. How about the range? Okay. When I look at range, well, this could work for domain or range. If you forget, for example, with domain, you're looking at x. So this, even though it looks like it's going straight down, you know that it's going to go all the way to the left. So it's going to go from negative infinity, and in here, it goes to positive infinity. So that's how I know my domain is going to be all reals. For the range, I work from the bottom of my graph up. So notice that it points all the way down. It's never going to stop. So that's going to go from negative infinity, and then I work my way up, and it stops right at 2 and includes that. So I put a bracket. Because we don't want to write 2 comma negative infinity. That doesn't make sense in interval notation. You always want to start from the bottom and work your way up when you're doing the range. Okay, y equals negative 1 over x. Okay, put it on your calculators if you want. This one is a... Why isn't that working? Okay, y equals... And then let's put in your negative. This is a rational function, which means it has a variable in the denominator. Okay, so it has 2 parts to the graph. Look familiar? This actually has a horizontal asymptote at y equals 0. I know it's kind of hard to see. It looks like it touches, but you know that it doesn't. And then a vertical asymptote also. So let's take that graph on your calculator and sketch it in the notes. If you want to put the asymptotes in, that's fine, but just gonna, I'll put them in here just so we remember. Again, sketch. I really don't need too many points. If you want, you could put the point at 1, 1, and then just know it gets closer. -1, -1. Just don't, remember, it's not gonna touch the axis. It's gonna just get closer and closer to it.
Oh, it's opposite
Yeah.
because it's a negative?
Oh, whoops, I drew the, I'm sorry.
Okay.
You're right, I made a mistake. Now that I know I can hold down, look at that, the button. Although I didn't have to erase my, okay, real fast. Go away. That's really messy, but you guys get the idea. Okay. Sorry, if it was positive 1 over x, it would have been in the first and the third quadrants. Okay, domain. So, Luke?
For the answer?
Oh, if you want. Or did you have a different question?
No, I was just gonna give the domain.
Sure, go ahead.
Negative infinity, comma 0, both vertices, union 0, comma infinity.
Good. So this one we did have to include the union because it's had the asymptote here and it jumped over. Again, working from left to right, notice the arrow points all the way to the left, so it's going to go negative infinity, get closer and closer to 0, not include it, jump over here, 0 to positive infinity. Now look at the range. So this part points all the way down to negative infinity. Oops. What's going on here? Negative infinity to positive. So it's actually going to be the same as the domain because it has a horizontal asymptote. I don't know why my pen's not writing.
You have to charge that pen.
It has a battery. I just have to change the battery, probably.
Oh, because it stops right at 0 and then goes.
Yeah, so again, looking at from the bottom, when you're doing range, bottom to top, so it goes, points down to negative infinity, but then it gets to 0. Got a problem there, we have an asymptote, so it's going to jump over 0, and then up to positive infinity. Okay so far? All right. Oh, do you remember what square root functions look like? If not,
When it goes like that, it just goes.
it's half of a sideways parabola.
Yeah.
Half of a sideways parabola.
Wait, what's the one where it goes like that?
Like,
It goes up and then back.
Yeah, that's the side. Yeah.
are you talking about this one?
No,
Side
it goes.
you're talking about
Here, I'll
side
draw it on here.
graphs.
I'll draw it.
Okay, you draw it out.
Here, look, it goes like
It's like a fourth tower.
like that.
It's like the power. Oh,
Oh, that's x to the third.
Bonus question.
Okay, so go ahead and graph 3 plus. So we have 3 plus, and then square root of x, oops, plus 4. Let's delete that. Okay, so there's half of my sideways parabola. If you remember the transformations, what's inside of the square root will be the horizontal shift. Okay, so since it's at x plus 4, we notice that it moved it to the left 4 units. And then the plus 3, or the 3 plus on the outside, moved it up 3 units. Now, so it went to the left 4, up 3. There's my sketch. Now, if you also recall, you could do domain algebraically here. Remember, if it's under the square root, it's got to be greater than or equal to 0. Right? It's okay to have a square root of 0. It's okay to have positive numbers. We just can't have anything negative. So this would be x greater than or equal to negative 4. So I know it has to be a bracket. Does that make sense? Why it's a bracket, not a parentheses?
But you can also look at the graph.
You can also just look at the graph, yeah. I mean, you can see that it starts at negative 4, right? And then how about the other part, the range?
3 to
Yeah.
infinity.
Work from the top, bottom to the top. The first point I see is 3. 3 is included to infinity. All right, questions?
For union,
it's a bracket because it starts at 4.
Right.
Negative.
Okay, and here's a way you can double check. If you go to your table, okay, so if I look at -4, if there was an error at -4, that would mean it doesn't include -4, but because it says -4, comma 3 in the table, I know for sure that it has an actual point there, right? Otherwise, it would have the error because that means there's like a hole or something in the graph. Okay, go ahead and type in 9 minus x squared. Have you seen something like this before? Probably not. Everyone's always surprised at seeing this one. This is an important graph for calculus. So the square root of 9 minus x squared.
It's the more it's like a mini parabola almost. Like this.
Oh wait, you can only have a couple numbers.
This is the right thing.
It's a
'Cause it-
rainbow.
Okay, this is a semicircle. Now, when you graph it, it doesn't look like a semicircle. It looks a little more stretched out. Do you know why this is? Go to Zoom.
That's just how.
Yeah, that's, you know your screen is actually rectangular. It's not a square. So it actually stretches things out horizontally. It does not give you an accurate view. Your window, so if you look at this viewing window, it's rectangular. It's not square. But the way that it labels it when you graph it in standard, it automatically goes from -10 to 10 and -10 to 10. So if you want a more accurate view, you go to Zoom, and then right here where it says square. And now it will give you the best view.
So what it'll do is with the sides, it'll make the window for the x-axis.
It just makes more x-axis. Yeah, it makes the x-axis longer.
Okay.
And then it basically, so now you see it does look more
Yeah.
circular.
Okay.
So if you ever want to get a better glimpse, like with it out being stretched, you could do the z square.
Can I switch this to -x squared plus 9 so it's easier?
You could do that.
Well, does it make it easier?
Okay, so if you were going to do this algebraically,
Mm-hmm.
Here, we want to make sure this is greater than or equal to 0. So I'm going to factor it. And then you put it on a number line, like here's -3 and here's +3. So if we check, this is going to end up giving us, like if we test a value to the left, it's going to be a negative number. If we pick something in between -3 and 3, it's going to give us positive, and this will be negative. Notice we want greater than or equal to 0. So we just want from -3 to 3. So putting it in the form of -x squared plus 9, not all that helpful for this particular problem, but sometimes it is. There's the graph. And then range goes from bottom to top. So the lowest value I have is 0. The largest y value is, remember, use your calculators. I'm okay with you relying on your calculators for now, but there will come a time that I want you to do more.
On our tests,
On-
will we always be allowed to have calculators?
No.
Wait, will you explain?
Did I answer that too fast?
Will you explain
Yeah.
what
Yeah, you want to think about it again?
Wait, so does that mean
Will you
you're
explain what
encouraging
the
me not to bring my
Oh, sure. The y value. Remember, when I'm looking at range, I'm working bottom to top. So I don't have any y values on my graph until I get here. This is 0. And then it stops at 3.
Why does it stop at 3?
There's no part of my graph above 3. Y equals 3.
Oh, okay.
Y equals 3. All right, got some more examples. I think just graphs on the next page.
Wait, so the range was -3?
No, it was 0.
0?
Yeah, because it stopped at the x-axis. Do you want to try E on your range? Was 0 to 3 in brackets.
Oh yeah.
Try E. Try E on.
Oh, because they were closed circles.
Yes,
The range.
they're
Okay,
close.
got it.
Okay, try the next one. It's the cube root of x squared. It's the cube root of x squared. Does it help if I do a quick sketch of the graph?
Cube root. Oh, yeah.
It looks like a,
I don't know what a cube root is. Oh, that's.
this is called a cusp. We'll learn more about them. It kind of looks like a square root going this way and a square root going that way.
Is it straight? It looks like one of those things.
It's
where you're
curved.
trying to make a bird when you're drawing it.
Yes. When you're a little kid and you're drawing like the little birds in the sky, it looks like that. It's called a cusp. I don't know.
So, but does it keep going up or does it eventually?
It keeps going. It keeps going up. It keeps going up. All right.
Are we not supposed to like know how to graph these?
You will get to know how to graph
But
these.
now we're supposed to use our
Okay,
calculators.
now I'm letting you rely on your calculator.
Figure it out if you just plug it.
Would I scare you if I said that I wanted you to have these all memorized?
Yeah.
What?
Okay.
This is already scary.
I said it's okay. Calculators are okay at this point. I'm already scaring you?
So they both just negative?
Well, I haven't seen this
Calculators are okay.
I prefer
So
the
are they
bottom.
both negative infinity to infinity?
What do you think?
The domain.
Are you asking me? You're telling me. Telling me. Negative infinity to infinity. Okay, and how about the range?
0 to
0 to infinity. Good. Okay. Okay, remember. You have a cube root. Now, notice that it has x squared. It's the cube root of x squared. So think about what's the smallest value that it could have under the cube root? It would be 0. Because think about any negative number, if you square it, it's going to become positive. And then the cube root of that just stays positive. But you can plug in 0. 0 is the smallest value you'll get out. But you can plug in 0. 0 to the 2/3 power is just going to be 0. Okay. Next one. We're not going to actually. Can I move to this page real fast? We're not going to finish this. There were just more examples. You guys can graph them and look at the domain. Maybe if I have time. I just want to get to a little bit more because class is almost done. Even I know. Calculus is a lot of fun. I feel bad that we're right now just stuck on this pre-calc review and then, but just wait. Just wait until we get to the calculus. It's lots of fun. I'm not just saying that either. I really love calculus. It's so much fun. Okay. Even in odd functions. Does that sound familiar at all? Yes. Okay. We know this. We got this. Okay. Even function. If you plug in negative x, you get back out the original function. If you plug in negative x here, you get out the opposite of what you started with. Okay, example. If I were to take this function x squared, if I plug in negative x, what happens when you square negative? It becomes positive, which means I ended up with the original function. So if I can plug in negative x and I get back what I started with, right, here's the original, that means it's even. A quick way to check is graphing it. It's symmetric with respect to the y-axis, which means if you were to fold your graph, like if you folded your paper along the y-axis, it should map onto itself. That's even. And then, so there's two ways to determine even and odd. One is algebraically, the other is...
Wait.
Oh,
Sorry.
sorry. I got to figure out this whole system here. It's not quite working for me. There you go. Okay.
I cut my mouth.
Oh,
That's like my one, like one.
oh,
That's like my
it's like
stash
nails
on
on the
the
board.
board, yeah.
Okay.
Same. I was in the library.
Okay. Not now. Not now.
No, I want to hear Josh's story.
The guy
Story.
across the street.
No. We'll have time for stories. All right. Okay, here, what happens when you cube a negative?
It's just
Negative.
A negative times a negative times a negative is still
Negative.
negative. So notice I basically ended up with the opposite of what I started with. And this one is symmetric with respect to the origin. So it means like if I have a point here, I also have it in the third quadrant. Okay. We did not finish. It's okay.
That'll keep you going with your studies.
Okay, so on Tuesday is when I see you guys next. There's just a couple problems that we did not get to. I do have that quiz planned for Tuesday. What we'll do on Tuesday is we'll go over homework, we'll finish the section. The quiz, like I said, is gonna be less than 20 minutes. It's not, and I won't include anything that we didn't cover. So it will be on lines, and it will be a little bit on domain range. And I don't know if I'll include even or on. You'll have a calculator. I'll let you use your calculator for the entire quiz.
And a friend.
Yeah, it's every other odd. It's actually very,
No, I'm not-
it's very
I'm just
reasonable.
curious.
Just there's gonna be problems at the end that we didn't get to yet. So when you get to that point, you don't need to worry about finishing it. I'm guessing, does anybody have their book? I can tell you.
Yeah.
Let me see. Get through. Actually, you can get through most of it.
Well, it's Friday.
Oh, piecewise function we didn't do.
Oh, I hated those.
Okay, up through 29 is where you can get. 29 is as far as you
On
can
page
get.
19?
Yeah. So actually, hardly any homework. So study the first section and what we covered.
I go to what?
20.
Well, it's every other odd,
But
but we didn't get through all of it. So
So 29 she said.
29.
Sorry, I'll
That's
get you
when
the
instead
technique.
of 1 to 60 minutes.
No,
Can
no.
we go over
No,
there?
my
Redo the
were
rest
about
of
to.
the
It's a horrible pencil.
We will.
Should get to
Oh, I'll
somewhere
do
with
it.
it. I just had to do it on my desk.
So
so I forgot it.
29.
Don't worry.
Oh,
I might take the time
Okay. All right, thanks guys. Have a great weekend. Email me if you have any questions.